Alright guys, here's the target 47 assessment readiness test key. This is the target where we're solving quadratic equations, and we learned 3 different methods. The first method we learned was by factoring. So basically you just take what we did in target 46, get them in factored form, and then solve. So number 18 kind of takes a baby step at that. It's already factored. We see x plus 6 times x minus 3 equals 0. The only way you can get something times something else equal to 0 is if one of those two somethings is equal 0. So you set each factor equal to 0 and you solve for x. So like this bottom one, I would add 3 to each side and you'd get x equals 3. This one you subtract 6 from each side and you'd get x equals negative 6. And you could check that. If you put negative 6 in for x, you'd get 0 here plus negative, or times negative 9. 0 times negative 9 is 0. So the method for solving them by factoring is to first factor, then solve each factor equal to 0. So for this one, I'm going to first factor. This one I can factor out a monomial. I can pull out an x from each of those. So if I do that, I'm left with x minus 3. That's as far as it can be factored. So now I solve each factor equal to 0. So that one tells me that x is 0. And if I were to solve the second factor equal to 0, you would get 3. So there's the two solutions, 0 and 3. This one, you can factor out any monomials, but it can be factored using either the box method or the shortcut method, since there is a 1 in front of the x squared. Using the box method, you ask the magic question, what adds to negative 2x and multiplies to 24x squared. So adds to negative 2, multiplies to negative 24x squared. So I think of my factors of negative 24, and hopefully you stumble across negative 6x and positive 4x, because those two add to negative 2x. So I put those in here, doesn't matter where they go. And then after I do that, I can factor out a GCF from both rows and columns. And then to make the last one both negative, I'm going to put a negative with that. So it's going to factor to x plus 4 times x minus 6. Now if you had wanted to use the shortcut method here, since the leading coefficient is 1, you can just put x and x here, and then the two numbers you put in the other two spots have to multiply to negative 24 and add to negative 2. So you'd come up with those, and when you solve, you get 6 for the first one and negative 4 for the second one. Don't forget to finish that problem and solve it. All right, the next two problems are dealing with solving with square roots. So to solve this with square roots, I'm going to undo to get x alone. So I'm going to undo the subtract 9 by adding 9 to each side. Then I'm going to divide by 16. So you get x squared equals 9/16. Now don't go ahead and put that in a calculator. Since 9 and 16 are both perfect squares, I want you to leave that. Square root both sides. And remember, when you undo a squared with a square root, you get two answers, plus or minus. And then just square root the 9 and 16 separately. Square root of 9 is 3, square root of 16 is 4. And don't forget the plus or minus. So the two answers are positive 3/4 and negative 3/4. You could also write that as plus or minus 3/4. Don't overthink number 22. Just square root both sides. You get plus or minus 5. Don't forget the plus or minus. Or you could write it as positive 5 and negative 5. Number 23 is the quadratic formula. So you first get it in standard form. which this one, oops. So the standard form is ax squared plus bx plus c equals 0. So we can see that the a is 1, the b is negative 8, and the c is positive 13. So now I'm going to put them into my quadratic formula. This is the quadratic formula here. Every time I see a letter, I'm going to put an empty set of parentheses. So that's read negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to go ahead and put these numbers in the appropriate spot. This is b, b, a, c, and a. Make sure you show that work. Now from here you want to simplify the three parts. This part, negative negative 8 becomes positive 8, plus or minus. This part, if you take negative 8 and square it, you'll get 64. 4 times 1 times 13 is 52. 64 minus 52 becomes 12. And then the denominator, 2 times 1 is 2. So now to get your two answers, you're going to round that square root of 12 off. You get 3.46. Keep a couple decimals with that. And now to get your two answers, you're going to get 1 by adding, 3.46, sorry. And then you're going to get your other answer subtracting. Again, you type that in your calculator, make sure you use parentheses. So I'm going to go ahead and type those two in. So I've got 8 plus 3.46 divided by 2, and 8 minus 3.46 divided by 2. So my two answers are approximately 5.73 and 2.27. Make sure you show all your work for that. It's the same idea for the last, or the next one. The only difference is first, you're going to have to add 17x to both sides and add 39 to both sides to get it to say equals 0. You have to get it in standard form first, then identify your A, B, and C. And then you just go through that whole process again. So it would be negative 17 plus or minus the square root of 17 squared minus 4 times A times C all over 2 times A. So that's going to be negative 17. The 2 on the bottom. These are big numbers, so I'm going to use my calculator for help. I've got 17 squared minus 4 times A times C. So that's 133, and then I'm going to end up taking the square root of that, which is 11.53. So now to get my two answers, I'm going to take negative 17 plus 11.53 in parentheses, divided by 2, and then I'm going to take negative 17 minus 11.53 in parentheses divided by 2. So the two answers, again keeping a couple decimals, negative 2.74, that would get rounded up to, and negative 14.27. The very last one is the same thing. It's just in the context of a problem. So what you would do first, since C represents a formula that gives the number of cars T years since 1971, and we want to find the year when the number of cars will be 23,000. So we first substitute 23,000 in for the C. Now before we can use the quadratic formula, we have to get it in standard form. So that means subtracting 23,000 from both sides. So if I were to take 6,655 minus 23,000, whoops. That gives me negative 16,345. Just bring down the other terms, plus 151t plus 20t squared equals 0. Now it's in standard form. We can see that A is 20, B is 151, and C is negative 16,345. So now you're going to put those into your formula. X equals, or actually T equals, in this case, we're solving for time, equals negative B all over 2A would be 40. And then here, I'm just going to do this part in my calculator. B squared minus 4AC would be 151 squared minus 4 times 20 times negative 1,000 or 16,345. Notice I used the negative key there, not the subtract key. And then I would square root that answer. I get about 1,153.43. So now to get my two answers, I'm going to take negative 151 plus 1,153.43 all over 40. To get my other answer, I'm going to do the same thing, except change the plus sign to a minus sign. And in this case, I get a negative time for my second answer. So the only answer that makes sense is the positive one. So I'm going to go with T is approximately 25.06 years since 1971. So if I add 25 years to 1971, it will be 1996. Or it's a little more than that, so it might be sometime during 1997, depending on what date this starts at in 1971. Okay?